Welcome viewers once again. So I am Dr. Varinder Singh in the course of Engineering Graphics. Today we will be covering the second part of the projections of solids. So that will include the positions of the solids, which are little complex than the previous one. So we may have the inclined solid. So what to do in those cases? So we will learn one by one. So our learning objective is again the descriptive geometry. So we take up the specific cases now. So here as you see, the axis inclined to one plane and parallel to other plane. So that is what we have to deal with in the beginning. So we may have two situations. The solid may be inclined to VP or solid axis may be inclined to HP. So in those cases we have to take an intermediate stage, that is called the initial stage. So initial stage we have to take in such a way that first the axis is perpendicular to some of the reference plane, and at the same time we will get the true shape of the base of the solid. And in the second stage we tilt the axis as per the statement of the problem, and then you get the distorted view of the base. The reason for the initial stage is we are basically given the geometry of the base. We get the definition of the solid in terms of the geometry of the base. So we need its a true shape. So the initial position without any inclination of the axis is needed in the beginning, and then we can move on to the final stage. So there are two cases. One case is the axis is inclined to the ground, or HP also sometimes, if it is in the or basically inclination with HP and inclination with the ground, that means the same, and generally we refer to the point ground when the object is in the third quadrant. When the object is in the first quadrant, we say that the object is placed on HP and it is inclined to HP, or maybe its axis is inclined to HP. So as I mentioned earlier in the beginning, that mainly we have to use the third angle method of projection in this projection of solids, or we are using in our book also the third angle method of projections. So we will all see the one type of problem where the inclinations are defined with respect to the ground, but it should not hinder the development of the projections in first angle also. So because there is not much of a difference, but for simplicity, so we shall cover all problems related to the projections of solids in third angle. Now if the axis is inclined to the ground, then the initial stage, the true shape of the base will be in the top view, and in the front view the axis is perpendicular to the ground. On the other hand, if the axis finally is told to us to be inclined to VP, in that case the initial position will be chosen in such a way that the front view gets the true shape of the base. So these points will be clarified as we move forward. In addition, the statements of the problems, they may include statements like it is resting. That means rest condition. It is resting on some surface with maybe base corner, maybe base edge. So what do we mean by that? So that is what we have to understand clearly. So by base corner we mean the vertices of the base. So like these. In one of the base corner, if it is resting, so that means it will be tilted. The solid will be tilted. So it will be kind of tilt. So kind of a tilt will be there. Okay, so then it may be said it is resting on this corner. So there are few more examples. If it is resting on the base edge, so then we may say this whole base edge. So we are focusing on. So if it is resting on vertical face, so then we should understand that we are talking about this particular vertical face. Here we are talking for prisms. So for prisms, if these points are used or these particular nomenclature is used, understanding should be, so vertical face is this one, sorry, so this is the vertical face, and this one which I earlier told, that is the vertical edge. So these are few of the possibilities in the case of prisms. Then for the case of pyramid, so the base corners, they remain the same. So these are the base corners, and the apex means the top corner, and the base edges, so these are it may be on base edges. So then this is the base edge. So the slant faces, so we have the slant face here. Okay, so this is the slant face, then slant edge. The object may be lying on ground on any of these features. So it may be on base corner, with base corner on ground, apex on ground, base edge on ground, slant face on ground, and slant edge on ground. So these are the things which may commonly encounter. So for the cones or cylinders, we may be told the solid is resting on its circumferential point. Okay, so then we must understand that any point on the circumference of the base, so that may be the thing. It may be resting on the generator. So for the cylinder, it can be the circumferential base point. Circumferential base point is there even in the case of a cone, but the generator, it may be generator in the case of cylinder. In the case of a cone also it can be generator, but the generator in the case of a cone is the slant edge, and it may also rest on the apex. So that is something we may commonly encounter. So now based on that, so how we have to choose the initial positions, so that we have to carefully decide in the beginning. So how to decide the initial position? So when it is told that it is resting on base edge, so very carefully we have to see that the base edge on which it has to rest, so it is drawn perpendicular to xy line in the true shape of the base. For example, if the solid is resting on its base edge on ground, then in that case the top view should be chosen as the true shape in the initial position, so true shape of the base, and in the true shape of the base, so we must ensure that one of the edge is perpendicular to xy line. So similar way, if it is resting on the base corner, we have to ensure that in the true shape the line joining the base corner, so that is parallel to the xy line. Okay, so similar way, slant face, if it is resting on the slant face, so we have to ensure that this the base edge which is contained in that slant face, which we want to, which ultimately is the one on which the solid is resting. So we have to ensure that that particular slant, that particular base edge which is part of the slant face on which it is resting, so that base edge is perpendicular to xy line. Okay, so and similar way, if it is resting on slant edge, in that case the corner, base corner contained in that particular slant edge, that should be at the extreme. So that is what we have to ensure. So these points we will utilize in the next set of example problems. So we shall take model solution 1. So here you can see the hexagonal prism having base edge 100 mm, height 150 mm. This is how the solid, hexagonal solid can be defined, because base edge 100 mm, that means it's a hexagonal, regular hexagon as the base with base edge 100 mm, and the height of the solid is 150. So it is sufficient to define the solid, given solid. So this information is sufficient. So this is resting on one of its base edges on the ground. When the base edge is on the ground, it has to rest finally with the base edge on the ground. That means in the final position the axis will be tilted. So and it is given in such a way that the axis is inclined at 70 degree to the ground and it is parallel to VP. So in this given condition, so we shall first neglect this inclination. Okay, so we will consider that the axis is initially at 90 degree. How it will help? it will help by ensuring that we get the true shape of the base, because true shape of the base is defined in the statement. So, we need to exploit that. So, what we will do, the true shape of the base will show up in the top view, and in the front view accordingly the solid will appear. So, we have to ensure that the base edge on which it has to rest, so that is perpendicular to xy line. So, you can see this is how the initial position can be drawn. So, first what we will do, so we shall draw the regular hexagon in the top view with the orientation that one of the base edge, let us say AB, that is perpendicular to xy line. We have xy line here. So, this is perpendicular to xy line because it rests on this base. So, further corresponding to this we can complete the vertical edges here. So, this is how finally the front view will look like in the initial position. So, why we have chosen this initial position? So, the care that has been taken is that the top view gets the true shape of the base first, and finally also we have seen that AB, one of the base edge, is perpendicular to xy line. Now, the next stage is to be used to fulfill the next condition. So, the other next condition is we have to incline the axis at 70 degree. Currently we have taken the axis at 90 degree. So, this axis is at 90 degree. So, finally it has to be changed to the required angle. So, you can see, so now we have made this angle as 70 degree. Okay. So, this angle has been changed to 70 degree, and now from this position, so we draw the vertical construction lines from different points. So, we are basically transferring from this view of the front, or from the changed front view, we have to obtain the top view. How do we get that? So, we are drawing the verticals from different edges, like from the bottom base we have 3 vertical lines, and from the top base also we have 3 vertical lines. So, those lines we are taking up, and finally, so before this let me show. So, we also have to take the lines from here. Okay. So, we ensure, so let us say for the top base, if we want to focus on the top base first, so then for the top base you get this line and this line and this line. Okay. So, now based on this, your new base takes this position, that is, it is the top base. About the bottom base, what you do? So, you need to go up again from here and from here and from here. So, from these positions again, so we get another base, that is the bottom base. So, for the bottom base, so we get this hexagon. Now, part of this hexagon which is in the bottom base, that will not be visible. So, that we have to that means this portion that is not visible. So, that we have to show by hidden lines. So, hidden lines we may use the cyan color, or the real practice in engineering graphics is to show them by dashed line. In AutoCAD we are taking a convenient route. So, we convert the line color. So, we change the line color to cyan if we are using the white background. If we are using the black background, we change the color to red color. So, that is what we do to represent. Now, I will show you the next position. So, you can see how, so this first I can draw the top base, then the bottom base, then I can convert the lines to hidden, or I can change the color, and in addition you can see the top base to the bottom base, the corresponding points are connected, but from A to A. So, from A to A this point is connected, but that is hidden because this is at the top, the one which is here. So, that is bottom base. So, part of that is not visible. So, the vertical edges also will not be visible. So, this vertical edge will also not be visible. So, whatever is not visible you have to show here. It is not isometric projection that the hidden lines are not to be shown. Here all hidden lines are to be shown. So, that is the distinction from the isometric drawing, and also it does not meet the requirements of the isometric drawing, but still, so you get some kind of 3D picture. So, you get the top base, you get side as well as the front view, some additional views you are getting. That is why little bit of 3D feeling you are getting. So, when you tilt the position of the solid, so it is a common thing. Okay, so this is one problem we have seen. So, now we take model solution 2. Here the axis is inclined to one plane. Here again the axis is inclined to one plane, and here that plane is VP. You can see the square pyramid having it is about the pyramid, it is resting on one of its base corners on the ground in such a way that the slant edge associated with that corner is vertical. Here the inclination of the axis is not directly defined, but the position of the solid is defined in such a way that the axis will automatically be inclined to ground. So, here again it is the case when the solid is inclined to ground. So, draw the projections of the solid if the axis is parallel to VP. So, now here it is a square pyramid. So, the initial position you can draw in the similar way as you have drawn in the previous problem. The initial position should be such that in the top view you shall get the true shape, okay. So, like this, and the corner, because it the slant edge has to be tilted, okay. So, slant edge is, so this position if you will take the solid in this position, so you will be able to tilt this edge in such a way that it can be made vertical like this, okay. So, this way somehow you will have to ensure. So, due to that reason the initial position is defined. Now, you will see how I have chosen the initial position. So, I have already explained why I have chosen this initial position. So, I wanted first thing in the top view, because here the axis is definitely inclined to ground. So, I take it initially as perpendicular to the ground, and accordingly I get the true shape of the base in the top view. True shape of the base in the top view I have got, and finally it is tilted around point C. So, it will be resting on the base corner. So, that base corner is kept at the extreme point, and in the second position. So, now this was the initial position. So, initial position neglected the inclination of the axis, or it neglected the condition given for the slant edge to be vertical. So, in the second position we fulfill that condition, and corresponding to this we know we will need to draw the top view. The top view, so what will happen if the inclination of this edge was not as much as it is shown here. If it is only this much, in that case the apex will go here, and from here the positions will be shown like this. Now, in this case O has gone to the position C. So, when O has gone to the position C, so what will be done? So, So from this O and from this O you take the new O, and from D and from B you get the new positions of D and B. Okay, so this position is also for C. You can see that the O and C, this is O dash, this is C dash. So from here, so you draw the vertical up, you will get the O and C on this line, and O and C from the previous top view, so they are also taken up. Similar way for A, the position is here. We know that the base edges, they will be joined in the top view, in the new top view. So A is to be joined to B, B is to be joined to C, C is to be joined to D, and D is to be joined back to A. Now A is also joined to O, B is also joined to O, C is anyway coincident with O, and D is also joined to O. So overall what you get? You get basically this is just the construction line, this is construction line. So overall, so your solid, it is somehow appearing something like this. Okay, so only two of the slant faces are now visible in this position. That is what I have drawn in the next position. You can see here, so only the two positions are seen. So how we reach this position? So that is very systematic. We have to draw the lines from corresponding points in the previous position and in the top view, and the new position front view, and the intersection of those points, they give you new points, and this way joining of the points so finally gives us the shape, the final shape. So this is the final position, this is the rest condition as defined. So we reach here in two steps. Now we take another model solution. So where we take the case of a cylinder. So a cylinder having 150 mm diameter and 175 mm height, it is resting on its curved surface on the ground in such a way that its base makes an angle of 50 degree to VP. Now the inclination is with the VP. You note this point. So here the inclination is not with ground. In the previous two problems it was inclined to ground. So here it is inclined to VP. That means we need to take it as perpendicular to VP in the initial position. So if the axis is perpendicular to BP, its base makes 50 degree. If the base makes 50 degree, the axis also makes a certain angle. So axis is also inclined. So if the axis is inclined so to VP, so then it has to be taken as perpendicular to VP, and if it is perpendicular to VP in the initial position, so you will see the true shape in the front view, and so true shape is the cylinder because it is a cylinder. So true shape of the base is the circle that is to be drawn in the front view. So this is how we shall draw. So the true shape, that is the circle, so we have true shape of the base drawn here, and the corresponding top view is here. Please note this nomenclature used in our book. So it is simply, it does not say that, so this is VP. So it says that this XY line in the top view is looking like VP. Okay, so the distance from the VP in the given position is taken as 2 grid spaces or 3 grid spaces. Yes, it is 3 grid spaces. So the meaning of representing HP and VP in our book, so that has been just explained. Now this was the initial position. So finally we have to see that this base, which is at 0 degree now, so this base is at 0 degree and axis is at 90 degree. So now base is at 0 degree, finally we have to ensure that the base makes an angle of 50 degree. How do we ensure that? In the next position we tilt the base in such a way that, so this whole thing, so we shall draw like this. Okay, so you see that here it can be tilted in either direction, that does not matter. Okay, so the base has been tilted so that it makes an angle of 50 degree as defined in the problem. So, as defined in the problem here, so we have given the inclination to the base by 50 degree. Now, see that it is third angle projection, and here whatever we view from this side, that is drawn here. That means this base will be the visible base in the front view, this base will be the hidden base in the front view. So, now because initially without tilt it was a circle, when this circle has been given an inclination, so in the front view it will appear as an ellipse. So, whose minor axis will be given by this one, okay. So, and whose major axis will be equal to the diameter of the cylinder. So, these points, these 2 points, they give you the major axis, and these 2 points, this one and this one, they give you the minor axis, and here you can fit the ellipse. Similar way you will get another ellipse, so corresponding to the bottom, but here for that you know that half of the ellipse that has to be shown by dashed line or maybe by the red color line if you are using the otherwise black colored line, and the line of tangency, so they have to be drawn. So, you can see the final position that has been shown here. So, this one should be the hidden one, so that you ensure. So, this is the solid one, okay. So, this is the solid lines, and you see, you can just see that I am just overlapping the diagram. So, this is how the cylinder will look like. Okay, in the front view if placed in the defined position. Now, we have 4 or 5 problems. So, now in the next problem, what do you see? Again a cylinder is there having diameter 125, height 125, resting on its circumferential point on base, circumferential point of the base with axis parallel to VP. That means it is making an angle with the ground. So, it is making an angle with the ground. So, and angle is also given in the next line. So, 45 degree line, 45 angle. So, you see here again the true shape we have drawn, true shape of the base, that is the circle that we have drawn in the top view, because the inclination is with the ground. So, with the ground we in the initial position we take axis perpendicular, and the given condition, the required condition of the axis making 45 degree with the ground, that we fulfill in the second stage. So, in the second stage we fulfill, and from there we draw the solid again, and we draw the bases, okay. So, and finally in the top view this is how the cylinder will look like. The top base will be visible, the bottom base will not be visible, and we must note that if the initial position is not there, we will not get the points for getting the distorted view. So, the requirement of the initial position is that you directly cannot draw the apparent shape as it appears. Okay, so this we are obtaining by using the reference points. In case of cylinders, using the AutoCAD, maybe to some extent we can calculate and we can do it, but for the other solids, the two stages are always needed. So you take another example. So this is how it will look like, and we take the case of a cone, and we have already seen in the case of prism or pyramid, etc. So that transfer of points, how much it was needed, and how the initial stage that was helpful in transferring the points. Now we take another very important position. You have already learnt it in the previous video lecture. Now the cone is having the apex towards the observer. When the apex is towards the observer, so what is the condition? So you can see, if this is the quadrant system, so we are in the third quadrant, so the cone is here, so the cone apex is away from the observer. If the apex is away from the observer, so then the top view will look like this and the front view will look like this. When the axis, here it is told that the axis is inclined at 50 degree to the VP. When the axis is inclined at 50 degree to VP, that means initially it has to be drawn as perpendicular to VP. So this is VP. Okay, so this XY line is VP in the top view, that we must know. So in the top view, XY line appears, or VP appears as XY line, and the angle with respect to XY line is angle with respect to VP. So we, in the initial position, it is 90 degree, and the position that I have drawn, it is the opposite position, where you are this side, you are viewing from this end, and we have this VP here. The object is in third quadrant. So in that case, if the apex is away from the observer, so then the cone will appear as upright. But in the given position, when the apex is towards the observer, the cone is actually like this, and due to that, the top view is such that it is finally appearing as inverted triangles, because as per our convention, so we rotate this HP in such a way that the front view will remain below XY line and top view will go above the XY line. So this is how we get the inverted triangle. And here, once we get this thing, this point was already explained in the previous case, but this was again explained. Now finally the axis is to be made at 50 degree to VP. So what we do, so currently the axis is at 90 degree, so we change its in the next stage. What we do, so we tilt this whole thing we copy and we paste here, and then we give this angle which was earlier 90, so then we rotate it by 40, so that the tilt of the or the inclination of the axis, it remains as 50 degree. So this is what we do, and from here you are clear that the base, if you view from the front, this is the front view here at the bottom, that is what we are drawing, the apex will come here. So this is the point of O, and your base will be within these points, and these 2 points, that gives you the minor axis, and the points here and points here, that gives you the major axis, and you draw the base, and you know that the from the corners, so from the apex you make the tangents, and you have to ensure that this base, which this portion of the base which is not visible directly, because this is at the bottom, or this is on the rear side, this is the front side. So, this rear side of the base, which is hidden behind the rest of the cone, so that has to be drawn by the dashed line. So, that how you do that. So, you can see here. So, but this it is not to be drawn by, let us say, simply cutting the circle into 2 halves. It is to be drawn by using this as the cutting edge. Okay, so this is the cutting edge. Then 2 ellipses you will draw, and one ellipse you will trim this portion, another ellipse you will trim this portion. One of the ellipse you can change the color. So, many of the videos on AutoCAD, they have also been prepared, so you can go through them. How you have to actually do it on AutoCAD, you can learn. So, here we are just trying to give you a glimpse of the conceptual understanding behind these drawings. Okay, so this one is the last problem. Here the cone here is making an angle of 40 degree to the ground. It is resting on the circumferential point, and the axis is making 40 degree to the ground. So, that is very simple case. So, we initially draw the initial position here. So that the axis is perpendicular to the ground, and then your true shape is there in the top view, and finally you tilt the cone in the next position, so that the axis now changes its position to, or its inclination from 90 to 40 degree with respect to the ground, and then you transfer the points and you get the job and you get the projection of the solid in the final position. So, this is how you deal with the different positions with respect to the projections of solids. Okay, so regarding the transfer of so this is all. So, we have for the projections of solids. In the next part of the lecture, we will see the transfer of points. So, thank you.